My dear students, today I would like to explain nuclear forces. This topic is very important to the point of examination. Before studying nuclear forces, first we should know about nucleons. We know that the nucleus is composed of protons and neutrons. No doubt, a proton has a positive charge and a neutron possesses no charge. Protons and neutrons in the nucleus taken together are referred to as nucleons. Next, in lower classes, we studied that like charges repel each other and unlike charges attract each other. Actually, the nucleus contains protons. These protons in a nucleus should repel each other. Due to this repulsive force, the nucleus should be highly unstable and must eventually break into smaller fragments. But many nuclei are known to be stable. Hence, a new type of force must exist between nucleons to hold all of them together. The nuclear force is the force holds the nucleons together is called nuclear force, or binding force between the nucleons is known as nuclear force. Once again, I am repeating, just the force holds the nucleons together is called nuclear force, or we can define in another way also, binding force between them or between the nucleons is known as nuclear force. Now, let us see about characteristics of nuclear forces. First characteristic, that is, nuclear forces are strongest force in the nature. That is, nuclear forces are highly complex in nature, very much different characteristics from gravitational forces or electrostatic forces. Their magnitude is about 10 raised to 37 times that of gravitational forces and about 100 times that of electrostatic forces. The second characteristic is the nuclear forces are always attractive forces. Nuclear forces are always attractive forces. Third characteristic is nuclear forces do not obey the inverse square law. Actually, inverse square law says that the force between two particles is inversely proportional to the square of the distance between the two particles. We have to consider here the distance between the two nucleons. Fourth point is nuclear forces are extremely short range forces. Actually, it is about 10 raised to minus 15 meters. In a nucleus, the two nearest nucleons have been found to exist at a distance of 1.9 into 10 raised to minus 15 meters apart, where the force of attraction between the nucleons is appreciably strong, or the force is maximum. If you increase the distance between the two nucleons to 10 raised to minus 14 meters, the force of attraction, the nuclear force rapidly decrease and it becomes to zero, or we can say here the nuclear force is negligible. That means at 10 raised to minus 15 meters, that means distance between 10 raised to minus 15 meters, the nuclear force is maximum, and at the distance, that is distance between the two nucleons is at 10 raised to minus 14 meters, it is approximately equal to 0. That means it does not obey the inverse square law. That means nuclear forces do not obey the inverse square law. At 10 raised to minus 15 meters, it is maximum. At 10 raised to minus 14 meters, it is negligibly small, or it is approximately equal to 0. That is, nuclear force is approximately equal to 0. Next, fifth point is nuclear forces are charge independent. That is, a force between a proton and a proton and a neutron, or a neutron and a neutron is the same. That means these nuclear forces are charge independent. Just now I said protons are having positively charged and neutrons are having no charge, but nuclear force exists between protons and neutrons is same. That means nuclear forces are charge independent. Sixth point is nuclear forces are non-gravitational. Nuclear forces are non-gravitational. Seventh characteristic is nuclear forces are exchange forces. The nuclear force between two nucleons is due to the exchange of pi mesons between them. Eighth point, nuclear forces are not central forces. Nuclear forces are not central forces. That is, the force between the nucleons does not act along the line joining their centers. Not act along the line joining their centers means actually here these are not central forces. Ninth one, nuclear forces have the property of saturation. That is, the nucleon attracts, each nucleon attracts a limited number of its neighboring nucleons or neighboring particles. Actually here neighboring nucleons only, neighboring nucleons. Each nucleon attracts a limited number of its neighboring nucleon. 10th one, nuclear forces are spin dependent. These nuclear forces are depending on the spin. The force existing between the two nucleons having parallel spin has been found to be stronger than that existing between the two nucleons having anti-parallel spins. These are the important characteristics of nuclear forces. Dear students, if you get any doubts, please contact me through WhatsApp. All the best. Okay, thank you.